A frightening divulgence made by the James Webb Space Telescope revealed what appeared to be city lights in space. Found 7 trillion miles from Earth, this groundbreaking discovery has ignited interest in the possibility of extraterrestrial life. The telescope focus on Proxima Centauri, be the closest exoplanet to Earth, uncovering odd bright lights emanating from it. What could be the cause of these city lights on Proxima Centauri? Could this indicate the presence of life beyond our planet? Join us as we delve into how the James Webb Space Telescope detected these unusual phenomena in space. For years, researchers and the general public have speculated about and explored the possibility of life beyond our solar system. Any evidence supporting this dream has been eagerly received recently. Mainstream scientists were astonished when strong evidence of living entities existing in space was observed by the James Webb Space Telescope while exploring space and transmitting data back to Earth. The telescope noticed unusual city-like lights shimmering from the exoplanet Proxima Centauri. These lights, as their name suggests, appeared to illuminate a distant city. The possibility of an alien city existing on the star has left researchers in awe. They are puzzled, as this could represent the evidence they've been waiting for. If this turns out to be true, as many believe it might, it means intelligent beings are building civilizations unknown to humanity in space. We are just beginning to cover it while exploring Proxima Centauri, located 7 trillion miles from Earth. NASA engineers can't help but wonder how long these lights have been shining in space, waiting for humankind to develop the technology necessary to detect them. David Kipping, a space expert from Columbia University, describes Proxima Centauri, where the city lights were observed, as fascinating. He noted this because the star system closest to us has varying heating patterns that differ from those of other planets. Typical rocky plan are known to absorb sunlight and emit infrared radiation, but not this exoplanet. Its infrared nature is entirely different from that of its host star Proxima Centauri. This hints at a significant observation by the James Webb Space Telescope, JWST, which is capable of detecting infrared frequencies. The specific heat signature of Proxima Centauri will play a key role in uncovering the planet's atmospheric secrets. Thanks to the latest technology in infrared imaging, scientists plan to use the JWST to uncover the mysteries of its atmosphere. They also aim to assess the possibilities of life on this exoplanet. The James Webb Space Telescope has the infrared sensitivity needed to analyze what occurs on Proxima Centauri's night side, capturing even the faintest light emissions in the vast darkness. This is typically challenging for space telescopes, but not for the JWST, which can detect even the slightest light emissions from space. It is the ideal tool to verify the reports of city lights on Proxima Centauri's night side. Any artificial lighting in the universe can be identified by the telescope as long as it falls within a frequency band much fainter than starlight. Proxima Centauri has an intriguing relationship between its celestial components and surface features. The daytime side of the exoplanet contains numerous solar panels that harness the bright energy from the star. Its spectral edge also reflects incoming light beams at the same time. When Proxima Centauri completes its orbit around its host star, it experiences continuous periods similar to Earth's day and night cycles. During the day, it endures intense solar heat, while at night it cools down. The planet's composition determines its behavior. For example, if there's no atmosphere on Proxima Centauri, the temperature variations between its day and night sides will be extreme. Without the moderating effect of atmospheric gases, the day side will become scorching hot, while the night side will plunge into freezing darkness. The degree of temperature variation is a crucial subject for astronomers to study, providing a deeper understanding of Proxima Centauri's atmospheric composition with the JWST unmatched infrared imaging capabilities. Researchers can analyze the planet's thermal emissions to provide valuable information about its atmospheric properties. Interestingly, the James Webb Space Telescope's orbit around Earth aligns with Proxima Centauri's orbital period, allow for thorough observations of its day and night cycles within 11.2 Earth days. If Proxima Centauri b does indeed have an atmosphere, the next step is to study its atmospheric chemistry to determine whether it can support life. Key indicators of habitability include the presence of gases like oxygen, water, vapor, and methane. If these elements are found on the planet, it would suggest conditions suitable for life. Successfully identifying these elements requires researchers to carefully capture and analyze light rays passing through the planet's atmosphere. This is a challenging task, even with the JWST remarkable abilities to characterize planetary atmospheres. The James Webb Space Telescope, while powerful, does not have unlimited capabilities and can only observe a few of the nearest exoplanets to Earth. For detailed atmospheric assessments, astronomers are now looking toward ground-based observatories like the extremely large telescope ELT, which is expected to begin operations in 2028. The LT is designed to analyze the atmospheric composition of distant exoplanets and will provide data offering in-depth insights into their habitability. NASA researchers and the public eagerly anticipate the development of future space telescopes like these. Until then, the James Webb Space Telescope remains an essential tool in our quest to uncover the secrets of distant exoplanets. Despite its current limitations, the JWST has the potential to provide critical insights that could transform our understanding of exoplanetary exploration. Researchers have set a goal for future space telescopes to reduce the amount of bright light coming from a planet's host star, allowing astronomers to better observe the light reflected from the planet itself. They plan to achieve this by using masks or large external satellites shaped like an umbrella, similar to using your hand to block sunlight for a clearer view of an object. Reducing the harsh brightness from a host star will enable future telescopes to focus on faint traces of light from distant exoplanets, allowing for more detailed examinations of their atmospheres and potential to support life. However, this approach comes with challenges, as researchers must distinguish between gases produced by life and those generated by geological processes such as volcanic activity. Astronomers remain committed to understanding the characteristics of exoplanets to better identify signs of life and differentiate them from false positives. The Webb telescope represents a glimpse into the scientific advancements in exoplanet research, offering a preview of the remarkable discoveries yet to come as we expand our understanding and exploration of the universe. We are better positioned to comprehend its intricate workings and our unique roles within it. After surveying all the planets in space, researchers have yet to find one that harbors life. Despite decades of searching for signs of activity, the mission continues. Are we alone in the universe? The rationale for focusing on radio signals is their ability to travel vast distances across the cosmos without significant interference. These signals could potentially carry evidence of intelligent life attempting to communicate or broadcast their existence. The SEI Institute has dedicated itself to analyzing these signals, sifting through the noise of the universe to detect patterns or anomalies that might hint at intelligent origins. However, no definitive alien signal has been detected to date despite decades of diligent searching. The silence raises the question, are we simply not looking in the right way, or is intelligent life exceedingly rare? The discovery of potential artificial lights on Proxima Centauri, however, has reignited hope. If these lights are indeed artificial, they could represent the first tangible evidence of extraterrestrial civilization. Still, researchers remain cautious, as natural explanations for the lights must be ruled out before jumping to conclusions. This groundbreaking observation also underscores the limitations of current technology. While the James Webb Space Telescope is a marvel of modern engineering, its capabilities are finite. Detecting and analyzing faint phenomena like artificial lights or atmospheric signatures is an immensely challenging task, requiring not just advanced technology but also innovative techniques. Future telescopes such as the ELT and proposed space-based observatories like LIRE, large UV optical infrared surveyor, aim to bridge these gaps. These next-generation instruments will be equipped with the sensitivity and resolution needed to delve deeper into the mysteries of exoplanets, potentially uncovering undeniable signs of life as humanity advances its understanding of the universe. The possibility of finding life beyond Earth feels closer than ever. Each new discovery, whether it's the detection of unusual lights, atmospheric gases, or other anomalies, brings us a step closer to answering the age-old question, are we alone? For now, the search continues. Scientists, engineers, and dreamers alike push forward, driven by the hope that somewhere among the stars another form of life may be looking back, wondering the same thing about us: capacity to travel significant distances without getting dispersed or retained, dissimilar to different kinds of radiation. Because of this property, radio transmissions are bound to be recognized by the 42 radio telescopes that make up the Allen Telescope cluster situated in the Fountain Piles of California. Albeit the SCI Foundation has perseveringly checked transmissions of these radio transmissions produced by outsider life, no such transmissions have been distinguished for north of 30 years. Jill Tarter remaining parts confident about the odds of coming out on top, communicating a craving to empower Earthlings wherever to become dynamic members in a definitive journey for extraterrestrial insight. All of this went on until late reports from NASA showed that the James Webb Space Telescope spotted city lights from a planet close to Earth. The JWST is a monster card played by mankind to acquire a superior handle of the grandiose secrets in space. Sent off in December 2021, it is known as the best infrared imaging telescope made by mankind, furnished with the most progressive optical innovation accessible today. The James Webb Space Telescope can look past the cloak of inestimable residue to uncover the privileged insights of the universe. Its essential mission is to investigate the universe, looking for the primary worlds and stars that were framed billions of years prior. The telescope is planned with probably the most modern optical innovation in this present reality, roused by James E. Webb, a visionary NASA director who is a vital promoter for space investigation and the Apollo moon landing programs. The James Webb Space Telescope is worked with a remarkable cluster of instruments, generally cooperating to give unrivaled perspectives on the universe. This incorporates a close-to-infrared camera, a close-to-infrared spectrograph, a mid-infrared instrument, and a fine direction sensor that permits it to keep up with its exact situation in space. The Goliath reflection of the James Webb Space SP Telescope, comprising of 18 hexagonal portions, has been painstakingly created to catch faint light from the earliest universes known. To man, it is intended to work at very low temperatures, permitting it to distinguish frail intensity signals transmitted by far-off objects. Since it send off the James Webb Space Telescope has followed through on vow to give motivating disclosures, carry humankind nearer to understanding the universe, from researching far-off stars to planning the climates of faraway planets. The telescope's bits of knowledge keep on reforming cosmology and space investigation. Could the revelation of city lights on Proxima b be another section in this continuous astronomical investigation? The chance of city lights on Proxima b lights a serious discussion among researchers and space experts. Might we at any point truly be near the precarious edge of finding wise extraterrestrial life, or are we seeing a surprising regular peculiarity that we are misconstruing, while the idea of outsider civilization utilizing counterfeit lighting could appear to be fantastical? It compels us to face the significant inquiry of whether we are separated from everyone else in the universe. The James Webb Space Telescope's capacity to distinguish such weak transmissions, whether from fake or normal sources, opens another wilderness in space investigation. Proxima b being the nearest exoplanet to Earth in the livable zone of its star offers a thrilling and open door to examine whether it could hold on to life, whether microbial or smart. As the JWST looks at this far-off world in more detail, analysts are particularly keen on distinguishing components that could demonstrate a biosphere. The presence of carbon-based intensifies the right air structure and quite the potential for surface life that could be pretty much as complicated as life on Earth. The disclosure of fake lights would unquestionably be a forward leap of uncommon extents. Anyway, we should recollect that there are different clarifications for these transmissions. The gleam saw by the JWST could essentially be the consequence of Proxima b's interesting air conditions, where regular cycles like volcanic movement, lightning storms, or extreme sunlight-based breezes could cause strange lighting peculiarities. While charming, these conceivable outcomes should be precluded before we can unhesitatingly guarantee the presence of extraterrestrial civic establishments. The logical technique requests that we examine all potential normal causes completely prior to rushing to make judgment calls. A significant advancement, like identifying outsider innovation, would have significant ramifications for how we might interpret space, as well as for the fate of humankind. Assuming that we observe that Proxima b harbors life, it could reshape our whole comprehension of science and advancement, exhibiting that the structure blocks for life may be definitely more normal across the universe than recently suspected. Assuming the lights end up being proof of shrewd creatures, the inquiry becomes, what's the significance here for our position in the universe? The idea of outsider civilizations additionally prompts a progression of philosophical and moral inquiries. How might mankind answer the disclosure of one more clever animal groups? Are we arranged to connect, or would it be a good idea for us we tread carefully the presence of outsider life? Raises the possibility of experiencing creatures whose information, innovation, and social improvements could be a long ways past anything mankind has accomplished. This makes both a thrilling and frightening situation for the fate of human investigation past Proxima b. The James Webb Space Telescope is ready to keep investigating far-off planets and moons that could hold on to existence with its high-level instruments. The telescope can peer profound into the environments of exoplanets, looking for the indications of life that could exist in conditions far not the same as our own, notwithstanding Proxima b future JWST. Perceptions will zero in on various divine bodies, from gas monsters with a potential for moons that may be tenable to rough planets in other planetary groups that could reflect Earth's current circumstance at the same time as new advances in telescopes come web-based. The quest for life past Earth is supposed to grow ground-based telescopes, like the incredibly huge telescope L, expected to start tasks in 2028 will supplement the JWST endeavors. These cutting-edge observatories will assist with giving further bits of knowledge into the synthetic marks that could show the presence of life or the natural circumstances fundamental for life to, though flourish the chance of finding savvy life is likewise prodding further headways in the area of astrobiology, this part of science which looks at the potential for life somewhere else in the universe is quickly growing, assuming that the light seen on Proxima b end up being an outsider transmission. It will probably push astrobiologists to refine their techniques for identifying life in the entirety of its structures, whether microbial, plant, or creature, and to foster systems for speaking with extraterrestrial developments. Would it be advisable for them they exist as humankind proceeds with its investigation of the stars? We are not just trying to respond to whether or not life exists somewhere else, yet in addition searching for ways of securing and safeguard our own civilization in the event that other clever species have existed or still exist in the universe. Their disclosures and